Okay, so in this video we're going to be looking at the complex conjugate roots theorem. But before we go any further, it's probably worth recapping. If we had an equation that was ax squared plus bx plus c is equal to 0, the coefficients is a fancy maths word for the numbers in front of. So the coefficients are the numbers in front of our variables, x, and the c at the end is a constant. It's a constant because there's no variable beside it. Okay. If we had x was equal to 2 and x is equal to 3, these are called roots. If I had x minus 2 and x minus 3, these are called factors. Okay, so it's really important to know what a coefficient is, what a root is, and what a factor is. Also, roots satisfy the equation. As in, if I were to sub them in, if I was to sub in 2 for x, it should equals to 0 at the end. Okay, so the phrase that we use is satisfy. We should be able to sub it in and it should actually make sense. Okay. So how does this build into complex numbers? If a question said show that z is equal to 2 plus I is a root of this, how would we go and do that? Well, the same way as if it said show x is equal to 2 as a root. It should satisfy 2 plus I, if I sub it in for z, should satisfy the whole situation. Okay, so it did say given, but I changed it to show. So we need to show that 2 plus I, when I sub it in, it makes sense, it satisfies the equation. So all I've done is subbed in 2 plus I for z. I'm going to multiply out the bracket, so it's going to be minus 4 times all of this, and square this out, so multiply it by itself. Okay, so 2 by 2 is 4, 2 by I is 2i, I by 2 is 2i, which would give us the 4i in the middle, and then I by I is I squared. Minus 4 by 2 is minus 8i, minus 4 by I is minus 4i. We can see the minus 4i and the plus 4i cancel. Okay, well, can we go any further with that? We can indeed. We know that I squared is minus 1. And if you add all of these together, you'll get 0 is equal to 0. So we can say, therefore, 2 plus I is a root. Okay, it also says show that z conjugate is also a root. So what's the conjugate of z? It would be 2 minus I. So show that z conjugate is a root. Well, we're going to go and sub in 2 minus I. So show that 2 minus I is a root. Sub it in and multiply it out. Minus 4 by 2 is minus 8. Minus 4 by minus I, it'd be plus 4i. Here at the front, 2 by 2 is 4. 2 by minus I is minus 2i. Minus I by 2 is minus 2i, so we get a minus 4i. Minus by minus is plus, I by I is I squared. The minus 4i and the plus 4i cancel. What do I know about I squared? It's minus 1. And we find that z conjugate is also a root. So there's a theorem that actually comes out of this. If, and a statement, and I'll touch on it again in a minute. If the coefficients are all real numbers, and the constant is real also. So all the numbers in front of the variables and the constant are real. As in there's no i's here. There's no i's here, here, or here. And I know this is a root. Then I'm allowed to assume that the conjugate is also a root. And it's not an assumption. It's just a fact. It always holds true. Okay? That is a statement of fact. And this is the actual theorem then written out. So if z is equal to a plus bi is a root, I know this is a root. This is a root, it is given, of this. And I know c, d, and e are elements of the real numbers, as in there's no i's here, there's no i's here, and there's no i's here. And I know z1 is a root. Well, then I also know the conjugate of z is going to be a root. So if the coefficients in the equation are real and we know the root, then the conjugate of the root is also real. So I know z conjugate is also a root. It's also a root. I think I said real there, but I should have said root. Okay, and that holds true for all complex numbers equations. Okay, so consider the example above. The coefficients in the equation were real, i.e. therefore the conjugate was also real. But it's nice to show you an example where this would not hold up. So if the equation looks like 3 plus iz squared, 2 plus 3iz plus 5. Well, what do I know about the coefficients? They're not real numbers. There's i's present. So then the conjugate is not a root, as the coefficients are not real. They are imaginary. So again, the coefficients is a real key point here. Are the coefficients real or not? So the name of this law is the complex conjugate roots theorem. So another example for you. If the question just said solve these equations and give your answer in the form of a plus bi, look, you're expecting to have a complex number as your answer. If z's are present also in the equation, expect a complex number in your answer. If you're expecting a complex number, you're not going to be able to solve this via the guide number. Imagine, what would the guide number be? Be 17. What are the factors of 17? 1 and 17. That's definitely not going to add up to minus 2 in any way. So we know we're going to have to use the minus b formula, fill in everything into the minus b formula as normal, and we get the square root of minus 64. A minus square root. Well, remember, that's why we have i's. We know the square root of 64 is 8, so the square root of minus 64 is 8i. And look, what do they have in common? They're the conjugate of each other. So look back at what do I know about A, B, and C here? A, B, and C are all real numbers. Okay, then that only holds true because they are real numbers. Okay, similar to what I was talking about before, here you're asked to form a quadratic equation. We're given the pair of roots. We're told the roots are 1 plus 3i and 1 minus 3i. So at the very start of the video, I said the roots were x equal to 2 and x equal to 4. So the factors are going to be x minus 2 and x minus 4. So if the roots are z is equal to 1 plus 3i and z is equal to 1 minus 3i, the factors is achieved in the same way as if we were dealing with x's. We're subtracting 1 and subtracting 3i from both sides, and in this one we're subtracting 1 and adding 3i to both sides. And do not be intimidated at this point. All we're going to do is multiply them out, but take your time. This is where people make mistakes by trying to rush it. Okay. Z by z is z squared. Z by minus 1 is minus z. Z by 3i is 3iz. Then what do we do? Minus 1 times the second bracket. Well, it's going to be the entire second bracket, just with the signs changed. So it'll be minus z plus 1 minus 3i. Minus z plus 1 minus 3i. And take our time then. Minus by a plus, we're going to get minus 3iz. Minus by a minus is a plus, and we get 3i. Minus by a plus is a minus. 3 by 3 is 9. I by I is I squared. Being very careful. What do I know about I squared? It's going to be minus 1. Okay. Then it's a matter of grouping. Group everything with the z. So you can see I've color coded it. The z squareds are the only purple one. The z's are the green ones. So I've grouped them all together. and the constants. Why have I included the I squared with the constants and the i's with the constants? Because they don't have any z's. Minus 3i and plus 3i, cancel. Minus 3iz and plus 3iz, cancel. Okay, there, cancel there. Minus 1 and minus 1 is minus 2. What do I know about minus 9 and I squared? That's going to become plus 9. So it's 1 plus 9 is 10. And there we have our equation at the end. Okay, so you repeat that exact same process for all the questions. What about this guy here? So this question here in the top right hand corner, make sure you're going at z is equal to 5i and z is equal to minus 5i. So the factor would be z minus 5i and z plus 5i. And then you would just multiply the two factors together. So it's z squared plus 5i z minus 5i z minus 25 I squared is equal to 0. Z squared plus 25 is equal to 0. And that's that question done. Okay, what next? Okay, so how about this question? They tell us it's a root. We know for a fact it's a root. And now look at the coefficients. Brilliant. I know the coefficients and the constant are all real. So that means I know that the conjugate is also a root. I can use the complex conjugate roots theorem. Okay, so if I know it's a root, then I know if I multiply the two factors together, I'm getting another factor. And what do I know about factors? Factors should divide in evenly into this equation up here. So I've gotten my original two factors from the complex conjugate roots theorem. I multiply them together, and then I use long division. So z squared multiplied by what is 2z cubed? That's 2z. And then I'm going 2z by z squared is 2z cubed. 2z by minus 4z is minus 8z squared. 2z by 13 is 26z. Change the signs. Plus to a minus, minus to a plus, plus to a minus. 2z cubed minus 2z cubed is 0. Minus 9z squared plus 8z squared is minus 1z squared. 30z minus 26z is 4z, and we bring down our minus 13. Then you're asking, z squared by what is minus z squared? Would be minus 1. So we're going minus 1 by z squared is minus z squared. Minus 1 by minus 4z is plus 4z. Minus 1 by 13 is minus 13. Change all the signs. Minus to a plus, plus to a minus, minus to a plus. And they all cancel to give 0. So that means as it's divided in evenly, this is also a factor. So I know this was a factor, this is a factor, and this is a factor. If I know factors, I can find the roots. Well, I know that would give me the roots. I know that would give me the roots. And I know here, 2z minus 1 is a factor. So that's 2z is equal to 1. And z is equal to half is going to be the other root. So that's where this is coming from here. Okay, another question then asks us to form a cubic equation. So we know we're going to want z to the power of 3. A cubic equation with real coefficients. So I can use the complex conjugate roots theorem. Two of whose roots are z is equal to 2 and z is equal to minus 1 plus I. Okay, well, hold on a minute. The real coefficients means that not only is this going to be a root, but its conjugate is also going to be a root. So I know the three roots. Z is equal to 2, Z is equal to minus 1 plus I, Z is equal to minus 1 minus I. If I know the three roots, I can find the three factors. the 3 factors here. Okay, well, brilliant. If I have factors, all I need to do is then multiply out the factors to find the equation. So I start 3 brackets, slowly multiplying it together. Z by Z is Z squared. Z by 1 is Z. Z by I is IZ. 1 by the second bracket. 1 by the second bracket here is just going to give us the entire second bracket again, which is fairly easily done. And minus I by the bracket here, you'd get minus ZI. Minus I by 1 is minus I. Minus by plus is minus. I by I is I squared. Okay, tidy up that second bracket. Tidy up the second bracket. And then multiply in the first bracket again. So this Z into all of this. And the minus 2 into all of this again. And we get down to a lovely equation with real coefficients from our roots that were provided.